So some more information about integers. We can use algebra tiles to model and represent integers, and algebra tiles are the different color rectangle and square shapes. Red colored tiles will be used to represent positive integers. So if I look at the number 5, I can represent that by using 5 red tiles. So 5 red tiles, if I see it, is the same as having a positive 5. Blue tiles will be used to represent negative integers. So if I consider negative 3, I can represent negative 3 as 3 blue tiles. A really important thing to consider that we can have 0 by looking at a combination of 1 red and 1 blue tile. Because if you consider earning $1, positive 1, and spending $1, negative 1, we know you will have 0 left. So in terms of tiles, 1 red tile and 1 blue tile will always equal 0. So because it is 0, we can in fact think about it as a positive tile canceling out a negative tile. And this does have to happen in pairs, 1 red per 1 blue. If I look at positive 3 and negative 3, positive 3 would be 3 red tiles, negative 3 would be 3 blue tiles, and I have 1 0, 2 zeros, and 3 zeros that cancel out. After I do that, I do not have anything left, so that positive 3 and negative 3 does equal 0. If I look at negative 2 and positive 2, 2 blue tiles represents the negative 2, 2 red tiles represents the positive 2. Again, I have 1 0 there that cancels out. I have another 0 here that cancels out, and I can see that there's nothing left. So indeed that does equal 0. Now if we have a positive 4 and a negative 1, positive 4 is represented by the 4 red tiles. Negative 1 is represented by the 1 blue tile. I only have 1 0 or 1 pair in this case. So when that cancels out, I have 3 red tiles remaining. Can't get rid of any because there are no longer any blue tiles. So the answer to that is positive 3, since that is what I'm left with. Positive 3 and negative 4 we can represent with 3 red tiles, 4 blue tiles, there's a 0, there's a 0, and there is a 0. After I look at all my pairs to make 0, I am left with 1 blue tile. So those two integers together do equal negative 1. If we look at the first two examples, so the negative 3 and positive 3, the negative 2 and positive 2, these are both cases in which we have opposite integers. So the number values are the same, but they have opposite signs. One is positive, one is negative. This case of opposite integers will always have a sum of 0 because we will have all pairs, so one positive for every negative, and they will always cancel out. So the sum of all opposite integers is always 0.